dia a todos. Essa aula excepcional foi ministrada pelo Dr. Gorinho. Gostaria de convidar a atenção de todos para mais uma aula também vai ser excepcional. Vai ser ministrada pelo professor que se formou em medicina em 1994 na Universidade de Pádova, na Itália, obteve especialização em farmacologia e clínica em 1999, doutorou-se em endocrinologia e ciências hematológicas em 2004, atualmente é assistente na unidade de patologia humana e reprodutiva no departamento de medicina do Hospital da Universidade de Padova desde 2001 e é consultor da unidade reprodutiva de Brunico desde 2003. Senhoras e senhores, para ministrar a aula chamada SPERM VOYAGE, induz os senhores o Dr. Andrea Garolla.
Okay. Hi, nice to meet you. It is a very great pleasure to be here today. I'm proud to be here, and I want to thank Mauro Bibancos and his team. Mauro is not a normal person. Mauro is really a magician. He is able to transfer his heart to other persons. Everybody I knew here in Brazil told this to me, but I know him since 2015, and I hear him very frequently, also if the distance is so high, and there is a strong link between his and my group. I don't want to thank or to tell the name of all guys that in this day I've seen, because I don't want to forget anybody, but they are like Mauro. He is a real mentor, and the mentor is not that one teacher to his student. The mentor is a person that transfers the life and his experience, and that help in any moment of their life the students and the person who wants to learn. So thank you from the deep of my heart, Mauro. This is not are not words for the circumstance, but I believe deeply in this. I was uncertain about this topic because I knew that I had in front of me young people, students, and so I was uncertain to tell you a story, something of divulgative, or a scientific presentation. But I chose a scientific presentation, perhaps more boring, but I think that when people are very prepared in medicine, need new news about the topics that we research on. And so today you have to listen a scientific topic. Part of this topic is already published, but I wanted to bring you also unpublished data. Some of these data are have been proposed to many scientific journals, and I hope they will be published in due time. So the last part is really new, and is new for everybody, because I didn't show this data in the previous previous congresses. You are the first, and I'm so happy to show you here in Brazil. I am sure that here in Brazil there are a lot of Italian people, or people who have Italian origin, but I'm so linked with your country that I'm sure that in the past some of my parents were from Brazil. It's a journey. It's a journey that I think is very incredible, and is the journey where start of the life of everybody of us. I see this journey from one side, the side of the sperm, because I am an andrologist, and so I speak to you about sperm, but you will listen to the other side of the moon by the gynecologist of your university. The voyage of the sperm started very far, from 2015, when I was here for the first time. I didn't know Mauro, and Mauro didn't know me. In fact, the first time put the imaging of another Andrea Garolla that is the chief of the ships in Italy. I am, yes, I am this one. Okay. The second time, there is a problem? Okay, the second time is 2017, and I was proud to have the right photo. And during the COVID, we had just a webinar with my chief, Carlo Foresta, and now we can have a new meeting today with Mauro and his team. The sperm. When I speak of the sperm, I have to say that it is the smaller cell of our body, smaller than red blood cells. You can see the dimensions. It's very poor. We cannot fight with the oocyte. That is a very big cell. One of the biggest cells of our body. So against females we lose any time. But the sperm is an incredible cell, because the sperm, a single sperm, has 37.5 megabytes of information in its DNA. So you can count an incredible number of information, 1.6 thousand terabytes in an ejaculation of few seconds. The voyage is very difficult and very long. It's quite to go from here to North America. The sperm is to pass all the male genital tract and to reach the tubes and the ovary. Then it must recognize the oocyte, penetrate it, mix the DNA with the DNA of the oocyte, and to bring a healthy baby to us. So I think that it is a very important cell, a superhero cell. But we have to start from the beginning. Where is the beginning of this history? The beginning is in the seminal tubules, and you can see that to reach the final maturation, the sperm needs to go through an and important divisions. From one staminal spermatogonial staminal cells, we need 75 days to reach the mature sperm. From one staminal cell that is able to renew itself, we reach to 96 sperm about. 96 sperm. We have to pass through the first phases from spermatogonium to spermatocytes of first and second order to spermatids, round, elongated, and then the sperm. The first phases are named spermatogenesis, while the last phases are named spermiogenesis. And this lead to the division of the chromosomes from 46 chromosomes to 23, that matching with all sides leads to a new diploid cells. And the phases of spermatogenesis and spermiogenesis, excluding the renewal of spermatogonia, are 64 days. But there is a mandatory phase that is the transit in the epididymis, because the testicular sperm are completely immotile and are not able to fertilize the oocyte autonomously. In this transit, there is the miracle of motility. In this passing through, there is a strong change in the nucleus and in the sperm membrane. So the sperm change the morphology, change the membrane and nuclear composition, and acquire antigens to recognize the sperm and the oocyte and penetrate the oocyte. During the maturation, there is a change in the nucleus, because you know that the nucleus of sperm has proteins that are different from all the other cells, that are protamines, and are protamines that render the nucleus so strongly compacted and give the sperm this form, able to swim in semen, able to swim in female genital tract, and to penetrate the oocyte. And is also the zinc, this ion that is responsible to give the compaction to the nucleus, that is very few in the testicular sperm cells and grows in quantity passing through the epididymis, the prostate, and so the ejaculated sperm are very rich in zinc. And there are a lot of zinc transporter inside the testicles and along the male genital tract, able to enrich the sperm of zinc. And these are our experiments demonstrated that from testicular to epididymal to ejaculated sperm, that there is a strong enrichment in zinc of the sperm. And you have to consider also another important machinery of the sperm, that is mitochondria. Mitochondria are the engine to give motility to the sperm, and the D-names of the tail are the machine, and are able to give the sperm a very high motility speed. It reaches about 55 kilometers per hour. And we can study all the properties of the sperm by many tests that we usually perform in our lab. The sperm of early apoptosis to search for annexin 5 positivity, when the sperm goes through apoptosis, they externalize phosphatidylserine that is recognized by an amexinophile. Or the study for the viability of mitochondria by JC1, or all the other studies to check the compaction of the DNA and to check DNA fragmentation. But today I want to explain you, to tell you a new history, the history of the sperm membrane. We realized that the nucleus is very important because it brings the DNA information, but without the integrity of the membrane, the sperm is not able to fertilize. The membrane composition depends on environment and many segments, and is responsible for the sperm function. You know that every membrane, every cell has a membrane, but the membrane of the sperm is unique, is different from all other membranes. In membrane we have sterols, we have lipids and proteins, and the sperm has this composition. There are glycolipids and in particular the seminolipid. The seminolipid is only present in the sperm. You cannot find in other cells of our body. Then we have phospholipids, and we have cholesterol, and we have proteins. Proteins are ion channels, peripheral proteins, and integral proteins that are mandatory for all the function of the sperm. The capability for motility and fertilization depends strictly on the equilibrium between seminolipid and cholesterol. And now I show you this. Cholesterol is the molecule that regulates the fluidity of the membrane. More cholesterol, less fluidity. More cholesterol, less expression of all the proteins of the membrane. If you have a sperm rich in cholesterol, that sperm it doesn't able to move, is not able to fertilize. And the seminolipid, it is a glycolipid that is responsible of cell adhesions, is responsible of the normal spermatogenesis progression. So knockout mice for seminolipid are infertile. There is a spermatogenic arrest, no maturation towards sperm, and there is a meiosis block. So seminolipid is able to induce spermatogenesis, is able to induce acrosome reaction, the liberation of enzymes for fertilization, and of the fusion with the oocyte. By mass spectrometry, we are able to check the composition of the sperm membrane. And we compared the sperm membrane of 33 normozoospermic patients and 29 oligoastenospermic patients, infertile. We were able to identify 21 new phospholipids that are here shown, and we observed that the seminolipid is the most component of the sperm membrane, 86%. 12% of other phospholipid and cholesterol 2%. But pay attention. If you look at the seminolipid quantity in fertile patients, you find a lot of seminolipid. and it is very few in infertile patients. And the seminal lipid has a strong correlation with all seminal parameters. Better seminal parameter, better fertility, higher composition in seminal lipid. Then cholesterol. I told you that cholesterol blocks all the function of the sperm. So we need to remove cholesterol that is highly present in testicular sperm. So from the caput of the epididymis to the cauda, this organ, the epididymis, is able to remove cholesterol from the sperm. So the sperm is able to move. And there are the epididymosomes, some organelles that are able to remove the cholesterol from the sperm. And in many studies, both in calf, we observe that cholesterol reduces from the capital epididymis to the ejaculate, and we perform the same experiments in humans showing that cholesterol is very few in ejaculate of sperm, but is very high in sperm retrieved from the epididymis by final aspiration that we use to detect sperm inside the testicle. And you can see by the Filippi that is able to detect the cholesterol, that there is a high quantity in the epididymis that is very low in the ejaculate. And if you check the quantity of cholesterol of normosospermic and oligosospermic, you can see that oligosospermic patients have high, very high content of cholesterol that is able to block the capability to fertilize the sperm. So the sperm membrane of fertile and infertile patients are so different, with a very low seminal lipid in infertile and very high composition of cholesterol. So this is this equilibrium that render the sperm of infertile patients are not able to fertilize. The sperm bring the cholesterol by certain cells that are the cells that surround spermatogenic cells, and the seminal lipid from spermatocytes of primary spermatocytes. And through the spermatogenesis, they enrich on cholesterol and they decrease, and they increase also the seminal lipid. There are some proteins, that some little oligosaccharides that are able to bring or release cholesterol. And we performed these experiments to see how the sperm characteristics changes adding or removing cholesterol. You can see here if we use this enrichment of cholesterol, sperm are very rich of cholesterol, and there is a change in their motility. If you release cholesterol to sperm, this sperm reduce their motility and reduce their capability to go through acrosome reactions. And if you remove by cyclodextrin the cholesterol, there is an increase of motility and an improvement of acrosome reaction. No, I have no time to go through this part because we are late, but I tell you also that some part of cholesterol are oxidized due to infections or due to testicular trauma or due to temperature, and in patients with high cholesterol, we find also more oxidized part of cholesterol that are able to impair, to give a big impairment of fertility. And they are named oxysterols that are able to impair our tests to check the integrity of the sperm. But what about the passing through the female genital tract? You know that the female genital tract is able to attract sperm by 3 mechanisms. Thermotaxis, because there is an increase in temperature, particularly during the ovulation of the female, and chemiotaxis, because there is an increase of progesterone during the phases of ovulation, and also the currency of the motility of the tubes. The thermotaxis is able to attract sperm because in the female genital tract is rich in bicarbonates and is rich in albumin. Albumin and bicarbonates are able to remove cholesterol from the sperm, and this phenomenon leads to an increase of motility, an increase of sperm capacitation, and an increase of acrosome reaction capability. And the sperm has a sensor, a protein named TRP, that is able to feel the capsaicin. The capsaicin is the substance that makes the feeling for the chili pepper, the hot of chili pepper. And this receptor feel the capsaicin and feel also the temperature. And in this slide you can see that the expression of this receptor for temperature inside the sperm. And if you make the joke using the cyclodextrin of removing cholesterol or adding cholesterol, you can change the migration towards capsaicin and towards temperature. If you add cholesterol, there is a reduction of migration. If you remove cholesterol, there is an increase of migration. And also for chemotaxis, if you use the capsaicin, there is a reduction or increase of migration towards the gradient of this substance. So cholesterol, such as for semilipid, is mandatory for thermotaxis, is mandatory for remove the cholesterol, and is mandatory for for the sperm to recognize the oocyte and penetrate it. We performed an experiment with temperature. Young boys, very healthy, exposed to Finnish sauna. Why Finnish sauna? Because the testicles feel very well when they are at 2 degrees below the body temperature. So we wanted to check the sperm exposed to Finnish sauna. All the sperm parameters after 3 weeks of Finnish sauna were decreased, and pay attention, the composition of the sperm membrane was enriched in cholesterol. So the cholesterol was able to block the sperm motility. And also the oxysterol, the oxidized species were increased. And all our tests for mitochondria, for the nucleus, for fragmentation were impaired, also in young people. And there were other 3 months to restore the normalcy. And also the progesterone is able to increase and improve the chemotaxis of the sperm. The progesterone that is very high in female genital tract during ovulation. And we were able to check both acrosome reaction and sperm-egg interaction after sperm exposure to progesterone. And sperm exposure to progesterone by this receptor, ABDHD2, is able, that is present on the sperm membrane, is able to induce hyperactivation of the sperm, again capacitation, and again acrosome reaction. So this is the molecule that mediates the link between progesterone and sperm. And again, if you enrich the sperm by cholesterol, you block the interaction between progesterone and sperm, you block the motility, and you block acrosome reaction. The last part, have I 3 minutes to conclude? Or is finished? Mauro, 3 minutes? Can I? New data, unpublished and not still submitted. The last were submitted, this one is the first time for you. Mediterranean diet. We in Italy are crazy for Mediterranean diet. If you want to feel well, you have to look for this diet. But I think you have a diet that is very similar. Not yesterday at lunch or tomorrow. And later today. How to detect the adherence to this diet? There is a validated questionnaire that is very easy to perform, and we administered this questionnaire to all the people that came in our lab to perform semen analysis. Every day in our lab we perform 40, 50 semen analysis, and there are 3 levels of adherence to this diet. Low adherence, medium, high adherence, and high adherence. It's very easy to calculate. Our population has this characteristic of sperm, DNA, and adherence to the Mediterranean diet, and they are in the medium. There are people that are low, medium, or high, and our population is medium. We perform the correlation between BMI and sperm parameters with the adherence to med score. And we found a strong relation with BMI. If you are not adherent, you are higher in BMI, but there is an incredible relation with all semen parameters. Low adherence, very low, very poor sperm parameter. You can see with the sperm concentration, the sperm count, the sperm viability, the sperm motility, and in particular the sperm morphology. And there is just a change in sperm parameter if you pass from medium and from low to medium adherence, and even higher if you pass from medium to high adherence to Mediterranean diet. But I want to show the last slide that for me is incredible. When I saw these results, I was astonished. We performed mass spectrometry to the sperm of subjects with low adherence. to Mediterranean diet, and we found very low seminolipid and very high concentration of cholesterol. But our nutritionist performed a counseling to these people, and we checked them after 3 and 6 months of Mediterranean diet. And you can see the changes in their sperm membrane. An increase, very strong increase of seminolipid and very strong decrease of cholesterol. This is the reason, because to all our patients checking for a baby, we tell in the next month you have to eat in this way. And we are also performing studies on the ultra-processed food that, in my opinion, are a big problem for fertility and our health. So I want to conclude, I will show you later, but I wanted to bring you this news that for me are enthusiastic findings, to tell that the sperm membrane has never been forgotten, because it's so important, in particular for seminolipid to cholesterol. I think that the future of the studies in male infertility are not in the nucleus, about what we know a lot, but on the sperm membrane. And I remember you that when you perform assisted reproduction, you put inside the sperm, also inside the oocyte with ICSI treatment, also the membrane. So you have to remember you are putting inside, and a healthy sperm perhaps function better. And all this machinery of the membrane is important for reproduction. So the voyage of the sperm is a voyage that aims to reach the oocytes, but aims above all to change the sperm from the testicular structure, from the female genital structures composition. So it's, I think it's finished, and cholesterol is very important, and it is independent from the blood cholesterol. That's another obligation.
It's good having you with us. We have a time for one question. Could you tell us about this change in the thermal taxes? Which environmental problem that we have in our daily routine that affects more, interferes more in these thermal taxes? And please, at this point.
Thank you, Eduardo, for the question. It is a central question, because we are what we eat, and we are what we breathe from the environment, and this is just a part of the story that is very complicated. Yesterday at lunch we were talking about pollution, and I explained to my friends that in Italy the Society of Oncology has made a study about the chemicals that are present in the environment. And they demonstrated that in some parts of Italy, where there is a pollution from perfluoroalkylated substances, that substances that you'll find in your cooking or in some trousers or jackets for the rain. There are a lot of these substances. And by water, by vegetables, by meat, we can introduce these substances. And in polluted areas, these substances reach the same levels of testosterone plasma levels. This is incredible because these substances change our capability of our reproductive capability, both for female and males, but are also cancerogenic, a problem for cancer. So it is a big problem. And the other example was for benzene. I've seen that in your cities you use a lot the machine. We use also in our cities very few the bicycles. And this is a big problem because the benzene was found in cities like Milan, in cities like Rome, at the same levels of estrogens in females. So this is incredible, and also benzene is a problem for reproduction. Yes? So we have to make a strong reflection on the environment and also in what we are eating in this moment.